Right. Hello, good morning. So my name is Vasif. I'm from SAP. So I'll be today talking about generally data protection and what Schrems 2 ruling means for companies who are processing customer personal data. So I'll start first with some of the background on data protection, right? How it's impacting businesses and the changes that are coming with Schrems 2 ruling, and then different technologies you can employ or deploy to deal with all this Schrems 2 ruling stuff. Okay, quickly again, agenda. So first we start with Schrems 2 ruling, right? What it means for us, and then European Data Protection Board recommendations, how you can deal with Schrems 2 ruling, and then of course market response to the ruling, what they're doing, what sort of technologies they are using. And then I'll talk about some of the technologies that can be used to deal with this Schrems 2 ruling recommendations to put basically better controls on your data, which is sitting in a cloud or applications owned by a third party then. So first, quickly, a bit of background, right? So European Data Protection Regulations, so GDPR, we all know it started in 2018, and more recently in 2020, we have Schrems 2 ruling. I'll talk a bit more in the next slide about what exactly Schrems 2 ruling mean. But when you generally look into data protection regulations, right, it started with GDPR. Now we have these regulations in literally every country. So we are dealing with customers coming from India, China, Argentina, Brazil. Even these regulations exist sometimes at the regional level, like at the European Commission level. Sometimes they exist at the national country level, and even sometimes they exist at the state level. So we are dealing with a huge, complexity here, right? So, and now if you look at this slide, we are talking about 71% countries which already have legislation in place for protecting basically their citizens' data, and 9% of the countries are basically already in the draft mode. So it's just everywhere now, right? So we have to be ready to deal with these regulations, and we have to support businesses which are operating in all these different countries, how they can comply with all these different regulations that come into play then. So GDPR, the whole purpose of GDPR was basically to facilitate the free flow of personal data within the European Union while preserving the fundamental rights and freedom of individuals, in particularly their right to protection of personal data. So GDPR applies to any organization, right, who is operating business in European Union, or if they're dealing with data which belongs to European citizens. And then Schrems 2 ruling comes in 2020, right? So Schrems 2 ruling, what it does is it invalidates the EU-US Privacy Shield and other privacy laws, for example, Safe Harbor. And basically it says that these basically existing laws, they did not adequately protect EU citizens' data as per EU GDPR regulations when PII data flows between European Union and United States. So again, re-emphasizing, right, we are talking about by 2024, we are talking about 75% of global population will have their personal data covered under all these data privacy regulations. Now, what are the recommendations of this European Data Protection Board when it comes to Schrems 2 ruling? First of all, you're talking about data, it needs to be protected with strong encryption whenever you are talking about transmission of this data. And encryption must be strong enough to withstand attempted crypto analysis by public authorities. And you're talking to any customers, right? So they are particularly concerned about their data getting accessed by state and state authorities without their authorization. So the whole idea is really to provide control back to the owner of this data, right? So, and then the second point is the cryptographic keys that are used in encryption process must be maintained within European Union or European Economic Area. So you can see that there are many encryption providers around the world, but whenever it comes to localization of this encryption keys, typically we find big challenges or constraints. Customers, for example, coming from Saudi Arabia or coming from Brazil or Argentina, they will always find it hard to find a localized encryption provider in their regions. So the whole idea is basically to have these keys localized. And whenever we are particularly talking about European Union, then keys need to be localized within European Union boundaries then. And the next thing is the data exporter must be in sole control of the key measures such as pseudonymization, where data is stored and processed in a way that cannot be used to identify an individual. Right, so these are basically the recommendations. Now I'll jump into a bit of details about how you can deal with all these different regulations through different technology measures then. Right, so first let's start with key management service, right? So, or encryption key control. So the first idea is that if you're basically a customer, right, you're using services from a cloud or from any application provider, and typically your data is maintained on their applications or in the cloud infrastructure, right? Your data is stored, persisted there, and being processed. So the first thing is you need to bring up segregation of duties principle, which means that if your data is sitting in the cloud, right, or in the application, keys should be segregated and they should be in your control as a customer, right? So data on the application side, but the keys on your side. So basically you are holding the key, which provides basically access to your data. Right? And the whole idea is basically at any point in time, you could basically disable or delete that key whenever there is some certain threat. This means that your data, which is maintained even in the cloud or on the application side, it gets completely locked. Nobody can access that. So you're sort of holding a red button in your hand through this sort of thing, right? And what it does basically, this sort of arrangement that helps first protect you from any unauthorized accesses, and particularly when you're concerned about accesses coming from state and state authorities, right? Typically, they will go to the application provider or the cloud provider. They will present them some warrants, and they will get access to all your data, right? They can pick up everything, and they have everything. But with this type of arrangement, you are the controller of your data, right? So it means whenever a certain situation happens, you push your button, your key gets deleted. So your data, even it is sitting on the cloud side or in the application side, it's just gibberish then, right? Whoever accesses that data, it's gibberish. They cannot see anything there. And then, of course, we're talking about securing data against breaches by insiders and external entities. So insiders as well, right? So you can, through this sort of technology measure or mechanism, you can ensure that there are very limited set of people who are able to create keys and who are able to manage those keys and who are able to delete or disable those keys when certain, basically situation arises. So now when it comes to key management service or encryption key control, right, a red button scenario, there are again different levels of control you could get as a customer. The first one on the left-hand side is basically you could go to a cloud provider or an application provider. They provide you some features, functionality, which enable you to do encryption key control, right? But still you're talking about your keys or your key management service. It is provided by the same entity which is providing you the application or service as well, right? So, but still, if they are able to demonstrate that they have basically a setup where you as a customer have only access to those keys, you are controlling key lifecycle operation, then basically this works for you. So this means that at any point in time, you could come to this basically your, whatever service you have, push the button, delete the key, and your data on the application side is locked. So even the application provider or the cloud provider, they cannot do anything, right? So if you look at this all big hyperscalers, they do provide this type of mechanism to help you control keys. The second basically level is a bit advanced, right? Where you as a customer, you might have already invested into some key management systems or services. Typically big customers, they have HSMs like Thales or Fortanix, or sometimes they are using AWS KMS or Azure KMS as their centralized key management systems or services. In those instances, bring your own key functionality means that they can continue to create keys in their existing key management systems or services, right? And then they can securely bring those keys into the basically cloud provider side or the application provider side. So this means that what happens is that from their existing systems, they can manage key lifecycle, right? So their key, it is basically, brought into the cloud side, right? Into the cloud provider, whatever they are offering as a service. So you do the key import into that particular service, but from your existing key management systems or services, you continue to manage key lifecycle. So the good thing is that all your keys for all your applications, if you're a big enterprise, you can continue to generate from the same system, right? But for then a particular cloud or service, you can manage keys. The third one is probably the most important and the most powerful one, hold your own key, where again you have already adopted some key management system or service. Thales, Fortranix, AWS KMS, Azure KMS, or Google KMS. So the whole idea here is that if you're using any service, let's say from SAP, right? And so in that case, you do not need to bring that key onto the SAP site, right? You keep the key in your existing, basically, key vault or key store, right? So what happens is there is a key encryption key relationship between the key which is in your control and the data encryption key which is typically maintained on the application side, right? So there is a key hierarchy or a cryptography relationship between the master key which is in your control as a customer and the data encryption key which is maintained on the application side. Now the question is why data encryption key needs to be on the application side. The reason is that if you bring data encryption key also outside the application, it will introduce a lot of performance override latency. You don't want that. So the best model is always to have this cryptography relationship where you as a customer manage master key and data encryption key is on the application side. And then again, coming back to hold your own key, the whole idea is that your key stays within your existing key store. You come to application provider or the cloud provider, you only register that key. Right? So you provide basically the cloud provider or application provider access to your key, read access basically. So they can see the status of the key. For example, if you're deleting the key, if you're rotating the key, or if you're disabling the key, right? So whenever, for instance, you delete a key, or let's start with the rotate key. If you rotate a key on your side, the application provider or the cloud provider, they are continuously reading the status of your key. They detect your key has been rotated, right? And then at that point, they will start using immediately the newer version of your key. And in some cases, if you delete the key or disable the key, then in those instances, again, the application or the cloud provider service, they are continuously polling, checking the status of your master key as soon as you delete or disable key. The data encryption key, which is maintained on the application side, it cannot be decrypted anymore, right? So basically, it means the application stops running. So this is the most powerful control where everything stays on the customer side within their key store, and there is only basically a registration mechanism in place. And just coming to also, right, if you are aware of key management service or encryption stuff, so there is always FIPS standards you're talking about, right? So again, depending on your basically data protection requirements, you could adopt for different FIPS levels. So whenever it comes to key management service, we are talking about FIPS 142 level 2, which is typically a software key vault or software key store. And then we have FIPS 142 level 3, which is typically hardware HSM, hardware security module, which is basically more protected sort of key store than. But even if you're using any of these things, through this hold your own key or bring your own key, you could do all these different models. Bring the key into the application side completely, right? Export it, or you keep the key on your side and just do the registration mechanism. Right, this slide just captures again, right, the whole idea of key management service and how it helps work or enables you with these SHREMS 2 recommendations. You have absolute control of the key then, right? As I mentioned, you delete key, all your data gets locked. Nobody can access that data. This includes accesses coming from any unauthorized users or even authorized users or from state or in-state actors. And we talk about localization. This is another recommendation. So whenever you're building such system, you need to make sure that you're available in all these regions and wherever your customer is located, because keys need to be localized. Right? For example, if you're running business in Europe or you're a European customer, you need to have your keys localized, stored, created within European boundaries then. And I talked about key vaults already. The next important point is transparency and access control over the keys. Now, you customer become the owner of those keys, the controller of these keys. So you define who can have access to those keys from your side. It's not anymore the application provider just going and accessing your key or the cloud provider accessing your key. You define who from your organization are the key admins who can create keys and who can perform different operations on the keys. So you become the absolute controller here. Now, a bit more details on key management service, what typical features you should look into, because this will enable you with some of the SHREMS 2 recommendation. First one, right, you're talking about independent and secure key management, emphasizing the point that you are consuming services from the cloud, and if typically you are consuming key management service from the same cloud, then there is no segregation, there is no independence. So ideally, your key management system should be separated from the application or the cloud provider side. And then you're talking about applications running in many different setups, right? You could have applications running in the cloud, in your private setups, in your on-prem setups, right? Through this, basically, you could deal with all these different type of deployment scenarios, right? So you create keys, and basically you hook those keys into your application which are deployed in any of these setups then. So bring your own key in cloud provider key stores. So key stores, if you look at today, right, key stores, the cloud providers, they provide you many different services. Some of the services persist or store data, right? And whenever your data is stored in these services, you need a control of the keys, right? So the good part is some of the services, they are already enabled for bring your own key functionality. This means you can bring your key and use those for these cloud provider services. But today still we have many services on the cloud provider side. For example, in AWS, also in Azure, where services, they always are strictly dependent on native keys provided by the cloud providers, right? So that makes it a bit difficult for some of the services. Then you have to decide, right, as a customer, do you want to really consume those services where you do not have the facility to bring key from your side, and you are strictly bound to use the keys which are provided by the cloud providers, right? So basically, there's no segregation there. Sorry. And generally, whenever we are talking about now this key management service, typical functionalities or features you need to support, right? Or lifecycle operations, you as a customer comes in, you create a key, right? You could create a key in any of the key stores that you prefer, HSMs or software key stores. And then you should be able to do all these operations on the keys because you are the controller of the keys through this sort of technology then, right? So you could create key, you could rotate key, you could delete key, you could disable key. So all actions are basically coming from your side, completely in your control. And now when we look into some of the solutions out in the market, right? So you could do all these operations going into the, the tenant or a service, right? There is also possibility, many of these providers, they expose APIs, so you could basically hook into those APIs. You continue to use your existing key management system, as I talked earlier, right? You create keys there, and you invoke all these key operations in your existing key management systems. Right, and then whenever you're talking about such a key management system, right, so we are not just talking now about segregation of duties principle for the cloud, where the data is in a cloud, keys need to be outside of the cloud. We're talking about segregation of duties within the key management service as well now. So you strictly need to define roles within key management service. For example, a person who is a auditor role, he should not be allowed to create keys, right? A guy who's a key admin, he should be able to only create keys and do lifecycle operations. Then key user, he's a guy who can only consume keys basically, right? So strictly you need to define all these rules which are very, very important to ensure that your keys are well protected and only restricted set of people have access to those keys to perform all these operations. Remember, as a customer, if you delete a key, your data is gone forever. Unless you are using some HSM where they enable key export functionality, which means that before deleting the key, you can download key. And when you download key, it means that after some time, maybe 1 week, 2 weeks, or 1 month, you can restore your data back as well. But again, you're talking about the risk here, right? Because whenever key leaves the key store, right, it's not protected anymore. So you have to carefully watch out what is the best strategy for you guys. Okay, then quorum policies, first auditing of the accesses operation. Now key is very, very sensitive asset for you as a customer. And whatever operations are performed on your keys, they have serious implications. As I mentioned, your data could be gone forever, right? So you have to very carefully basically look into first who are the guys who are able to do these operations of key. And then in this key management system or service, you need to have all these audit logs in place. So you could see who is performing what operations on the keys, right? Typically, they are available in the key management services, and they also provide APIs so that you can channel those logs into one of your central SIEM system as well. Now, the next important part is quorum policies. So, for example, I am an organization, SAP, right? I am using some service from Google or AWS, let's say. and I'm persisting a lot of data on AWS side now. And I have some key admin. He comes to my key management service and deletes key. All data is gone, right? I cannot do anything now, right? So this is now very important where you have some sort of quorum policies in place. So not one single person can go and delete or disable your keys, right? You have to put up multiple approval steps in place so that whenever certain actions are being performed, they are basically controlled through these different workflows to enable multiple approval steps. Then transparency and control policies for keys. Again, as an organization, you need to ensure that who from your side are the people who can have access to those keys, or who are the key admins who can create keys and do different lifecycle operations on the keys. And you're talking about very selected set of people. And then, of course, all this information coming from audit logs about who is accessing key, what are key operations are performed. You have these audit roles typically who can create all these reports for you and also provide complete transparency on what operations are being performed on the keys. Right, that was on the key management service side. But important point is customers get control of the keys. At any point they delete key, their data is locked. Nobody can access data, not even state and state actors, not even the cloud provider, not even the application provider. For example, SAP, we provide applications to customers. We persist their data. Whenever they switch off, delete their key, even we cannot access their data anymore, okay? The next part is tokenization and anonymization, right? So again, these are very powerful technologies to help with stems to regulations because they also provide you very strong controls of your data sitting in applications or in the cloud. So whenever we are talking about tokenization, it basically, So what it does is basically it replaces original data with an alias or pseudonym. So what happens is that you as a customer define certain data fields which are very sensitive to you, right? For example, I am a customer, I'm dealing with social security number, passport number, or some other sort of HR data. And I need to make sure that this data is protected at the highest level. So typically, for production system, I will employ tokenization, which means that I define policies that these are certain data fields, very sensitive. I need to define tokenization policies on these fields. So this means that whenever a person comes in, right, he's entering his social security number into my application. Maybe he's entering for his passport application or for some other stuff, right, entering his personal data. At that point, based on your policy defined, policy says this particular fields need to be tokenized. Calls are typically made to the tokenization server. These fields get tokenized and then they are stored in the database. So important point is even in your database, the fields are tokenized. So if your database admins, right, these guys, if they sneak into your database, they cannot even see the real values. They will see the tokenized values. And then the important part is that you can also define de-tokenization policies, which means you can see a restricted set of people, right? They can only have access or they can view de-tokenized data. For example, I can configure a policy. A person who is US citizen coming from within USA boundaries and who is from HR department, only he can see de-tokenized social security number. And the good part is then this de-tokenization happens at runtime, right? So your data is always, protected, stored at the database layer in the form of tokens then. As I mentioned, then this is recommended for production system. And then you're talking about, and remember, right, you're talking about tokenization, it is reversible. So you can define a de-tokenization policy where you can still enable restricted set of people to see the de-tokenized data. An important thing is, right, if you use these different applications or even if you go to the cloud, your accesses are defined based on role, right? But through this tokenization stuff, what you're doing is even in all this set of authorized users, you're taking, again, a restricted set of people who are US citizens, belong to HR department, coming from US boundaries, only they can see the de-tokenized data then. Now, the next part is anonymization functionality. Anonymization, the good part is it is irreversible. Once you anonymize data, you cannot basically reverse it back to original data. So this is the best technology when you're talking about, you have systems, typically you do copy of your systems, right? For non-production usage, for development QA. In those cases, you do not or should not have your personal data sitting in this non-production system. So through anonymization, what you can do is basically you can change all this sensitive or personal data into anonymized data. And basically then you can still use that for, as I said, non-production usage, right? And as I mentioned, it is irreversible. That's the important point here. Now coming to a bit details about how you can realize tokenization, right, in your organization, because this is, again, right, as I mentioned, a very powerful technology. So what you do is basically, you could have, some rule engine first, right, where you define what fields you want to tokenize, right? So this is the first part, social security number, passport number, or whatever. Then you have typically an application where a user comes in and they are entering their sensitive data, passport number, social security number, some financial information, whatever is sensitive to you as a customer, right? So what happens is that whenever a customer enters their, let's say, social security number, at the point, in the application, then we have a policy enforcement point typically, which means that this is enforcing the policy which you define in your rule engine, right? Let's say here I've defined that my social security number or my birth dates, right, or my address, it needs to be tokenized before it is stored in the application. So what this policy enforcement point, what it does is whenever you're writing some sensitive data, it will evaluate, right, and then policy says, yes, this data needs to be tokenized. That point, it will make a call to the tokenization server, gets this particular field tokenized, and then this is stored or persisted in the database. So in database, you have tokenized data then stored. So when a database admin comes in, he cannot see the real value. Now the tokenization server, again, there are multiple models. Big customers, typically they have HSMs, or they are already having some key management system. They can leverage those, and there are also providers which provide this as a complete SaaS offering, which means that you get everything in a package, even the tokenization server, and you just start using it, go in their policy engine, start defining policies, and your whole thing works. Right. And of course, when it comes to tokenization, it's basically not just for Schrems II regulations. You are dealing with GDPR, you're talking about HIPAA, right? If you look into all this health sector, this is the most important functionality technology you need to have. Otherwise, you cannot even target customers coming from health sector. Right, so this is more about now the overall picture, right, about different technologies and how they work in coordination with each other, right? So you could have, again, any system or service where you are persisting your data. It could be provided by SAP or any other provider or by any cloud provider like AWS or what. So first of all, right, you're talking about, this whole activity monitoring or the transparency on what's really happening with your data sitting in the application. Who is accessing your data, from which geolocation, what actions are performed on your data, what are the user attributes? Because if you're talking about data sitting on the European side, belonging to European citizens, you do not want somebody coming from US, right? Even he's authorized according to his role, but you need to make sure because he's coming from US, I need to block his access, right? So you need to have all these mechanisms in place and transparency on that as well. Right? This is basically what we call then contextual access control. Typically in application, you do role-based access control. Contextual application control means now you're doing all this access control based on additional user attributes like citizenship, department, cost center, building. For example, we are dealing with a customer, right? He came from UK and they said to us, they have some very sensitive data sitting, right? And they wanted people sitting in a particular building only to have access to that data. So you're not just talking about the country, you're talking about people coming from a particular building, they should only have access to certain data. So you're talking about very fine-grained access policies, not anymore role-based, because role-based is not enough to deal with all these data protection regulations. And the big question is now, from where do you get all this context? For example, you are a user, right? You're a sales manager, you have access to certain applications, certain data. Now I need to bring additional context because I want to now control access. If, for example, you are coming from outside of USA, or if you are a just green card holder, right? This type of thing. So these attributes are available typically in systems like Active Directory, or if you're using SuccessFactors application, or there are many other user management systems. If you start looking into those systems, there are tons of these attributes available. So you could bring those attributes into any of your access solution, access control solution, and enable all these rules based on these additional attributes then. Right, I talked about already, encryption. Basically, data needs to be encrypted and key needs to be in the control of the customer. Tokenization, even at the database layer, you do not want your data to be exposed even to the database admin. So tokenization, you get the highest levels of controls. Now the next part is anomaly detection, right? So you come to your basically application, you are a customer, you have different data, right? You're coming from retail, you're coming from public sector, or what? You have different type of data, whatever you need to protect, right? You do all these different approaches, right? Context application, access control, encryption, tokenization. Still, you want to look into what is the user behavior? What is the resource utilization behavior? For example, I every day come from Palo Alto, access certain transactions which touch my HR data, right? All authorized. Today, I seem to be coming from Chicago and I'm accessing some other transactions which touch financial data. Completely legal, authorized, but this is not what I do every day. So these sort of anomalies need to be checked, detected, and these need to be surfaced continuously so the users can do proactive actions. For example, they can train algorithms, right? Say this is completely okay, or they can raise basically, incidents in the workflow to start investigating what's happening. So it's not about just putting up all these different technologies in place. Even after putting all these technologies, you need to continuously observe what's happening even with this restricted set of users who are accessing your data, because you do not want to even trust them completely. You want to see if there is any anomalous behavior, you want to detect that, and you want to do proactive actions then. Right, this then covers a bit of bigger picture, right? So I did not capture much about data discovery. So this is now, you are coming from different sectors, right? You're coming from retail, defense, you're coming from public sector. So different type of data is sensitive to you. For example, if you're coming from a food sector, right, maybe recipe data is very sensitive to you. If you're coming from public sector, different set of data is sensitive. So the journey always starts with data discovery part, which is, I am an organization now. I have data sitting in maybe one cloud, or I'm sitting in a multi-cloud environment. My data is scattered around, different countries. Different type of data is scattered around in different data centers. And typically I don't have good overview of what type of data is sitting where. So always the journey starts with data discovery part, which is to first detect what type of data is sitting where. For example, I am a UK customer, I have a localization requirement. My financial data needs to be localized, stored only within UK boundaries, right? So the journey really starts with this data discovery part where you do all this data scanning, right? Whole your cloud landscapes, your applications, and then typically labeling or tagging happens. Labeling or tagging means that my financial data, if I am using, let's say, S3 in AWS in, I don't know, Brazil, right? And my HR data is sitting there, and I have some other cloud, maybe Google in Europe, and my financial data is sitting there. So I start looking into, and once, through this data discovery, all this data gets labeled, right? So each of the resource gets sort of tagged or labeled that this particular resource has financial data, this particular resource has my HR data, or this has my PII data. Now you can use this labeling and tagging to simplify your policies, do abstract policies. For example, I can come in and I can put up a policy, all my data which is tagged financial, it needs to be stored always within UK boundaries. Or all my data which is tagged PII, personal data, it cannot be accessed by people who are coming from outside of EU boundaries or who are not EU citizens, right? Or whatever immigration status you want to put in. So data discovery essentially becomes the front runner, the prerequisite before you start then applying all these different technologies. For example, right, once data discovery is done, I can then decide what data needs to be localized within European Union, right? PIA data, also financial data, maybe some HR data, right? And then what data needs to be controlled based on access, right? Or based on contextual access, right? What type of citizenship, what type of guys can make access to certain type of data. And then of course, then you also decide what type of data needs to be tokenized. Some data which is highly sensitive, right? You need to protect even at the database layer, you go for tokenization and anonymization, which is then typically for non-production systems. And I think that's, yeah, that's pretty much. So I will stop here for questions.
Hi there. Thank you. Is it on? Thank you for the talk. A question. So the whole thing started about TRIMS and the dissolution of the EU Privacy Shield. What's your take on how we should be thinking about the replacement for the Privacy Shield? And like this is kind of the extreme version of what you need to do if Privacy Shield wasn't upheld or there is no replacement for it. What's your take on, is there an interim that's going to allow us to not have to use all these technical controls, but using more policy-based controls?
So we are dealing with customers every day now, right? And they are primarily coming to us because there's Schrems 2 ruling now, and this is a hard requirement now, right? So they are taking a position that we cannot go live with your applications or we cannot go live in the cloud if we don't get this type of controls in place. So as a application provider or as a cloud provider, you need to support all these mechanisms if you want these customers to be live on your platforms or on your services. So I would say it has literally become a hard or mandatory requirement. We don't have much time left to, for this sort of transition stuff. Yeah.
So I've got a question about key management. So bring your own key is really a mechanism which is multi-tenant, and the cloud provider normally holds the master key that wraps all the other keys. So really, in a sense, it isn't meeting the real needs of a, hold your own key or CC, the other one, the client's control key. So really, bring your own key is not a good mechanism if you look back at what the requirement is to start with, because the cloud provider is only promising not to access your keys. It doesn't actually have technical controls which stop the cloud provider from accessing your keys and therefore decrypting your data.
Right. So you talk about basically this middle, right? Bring your own key, where they enable some of these services, right? Where you can bring your own key, but of course the key needs to be stored in their provided key store ultimately, right?
Yeah.
But as long as they are able to provide you a red button, right? Basically a key delete mechanism, right? So you are still in the control, right? Whenever you push that red button, but coming back, I think that's where this hold your own key model becomes the best model then in the market, which means that your key is never leaving your key store. It stays in your key store. You only register that key for a particular service, right? And the cloud provider is actually only having read access to your key then. They can only come and see, if key is rotated, if key is deleted or disabled, right? They never get basically to perform any lifecycle operation on the key. They don't have any access then.
Yeah, when really bring your own key is not the right solution for most financial services clients, for example, will not use it.
We are dealing with financial services guys, they always go for hold your own key.
Yeah, they want better
But,
control
the problem is that whenever you're switching to this particular model, then your key store is hooked into the main service, right?
Yeah.
This means that whenever it comes to SLAs, high availability, then you become responsible as well, right? So there's a compromise as well then.
Yeah, exactly. I mean, if you do hold your own key in your own, often in your own HSM,
right?
It's, it could be that HSM is elsewhere, which means you get resiliency issues, or it gets very expensive. Or the other mechanism we use is keep your own key. We use a level 4 HSM to keep them actually in the cloud, but you have full control of the key. So that there is another mechanism that to your three there. As
Right.
Well.
And the good part with with bring your own key, you always need FIPS, 142 level 3, because you need to have HSM to be able to export key out and bring that into the other key store, right? But with this hold your own key, it works with software keys as well, right? You just need, for example, if you are using AWS KMS, you go to your AWS KMS, you create a key, adjust some policy, enable me read access to that key by providing basically a reference to the key, and then I'm able to read that. So it works for HSM, for software as well, right? Software key store. This one is restricted. You need to have HSM then in place.
Yeah, and I think level 2 software-based HSMs are not really, shouldn't be used.
Right.
In most cases as well. So level 2 is not really an option unless it's actually the crypto library that's associated. You want a FIPS crypto library used on the host or something like that. So then you need level 2.
So I can tell you, we are dealing with many customers coming actually even from financial sector. When it comes to hold your own key, they are even okay with software key stores as well, FIPS 142 level 2. Because even with that, they get ultimate control, right? They can switch off and everything is gone.
Yeah, I think it depends on the financial services organization. Yeah.
Yeah, we're talking about some of the banks, for example, the big ones.
Yeah. Okay.
Yeah.
Thanks.
You're welcome. Any further questions? All right.
Thank you.
Thank you for your time. Thank you.